Hello everybody. Lesson M10 is to fold a kinetic octagon, also called magic octagon. Now let's look at the folding diagram.
Start with a square paper. Valley fold and unfold on the two diagonal lines, then the center line. Mountain fold on the other center line. Bring the two parts together to form a balloon base, which is used to fold a balloon and many other models, including the kinetic octagon. The folding demonstration follows in next video. Valley fold the diagonal. Valley fold the other diagonal. Valley fold one center line. Mountain fold the other center line. Bend center, bring two folds together, press down, that's the balloon base. Fold the right edge to the center line. Repeat the same fold. This is first module. Replicate 8 modules and assemble them. Each module has 4 flaps. Each flap has a pocket. Bring another module and assemble them. 2 black flaps go into the 2 red flaps. Insert them and push tightly together. That form a diamond. Connect only the top layers. Valley fold along the center line. The bottom layer will be connected later. The 2 modules are connected. Repeat the connection for the other module. The last insertion is no different. You insert the 2 blue flaps into the red flaps and push tightly and fold along the center line. Now it's all connected. Let's play. Bring all 8 tips to the center and then press down. You got octagon. And then bring all the tips up and outward, you get a star. Then repeat. Next is OMG challenge on the math. If the paper is a square 1, we fold this octagon. How big is it? How long is each side of the octagon? The diameter and the internal angles of each module. You may pause the video and solve these problems. A hint is to find out all the sizes of the balloon base. For the square 1, the diagonal length is the hypotenuse of the right triangle, which can be obtained by the Pythagorean. For the balloon base, one side is a half of the diagonal length. The height is 1/2. It is an isosceles triangle with 2 equal base angles, half of the 90 degree. Now try to find the size of the octagon using the spatial reasoning. Finally, is the challenge on the creativity to create a unique art. The first example is the combination of the 8-point star and an octagon. Place an identical octagon inside the 8-point star to form a new art. The selection of the paper pattern is the creative thinking. Next example is a combination of 4 octagons in different sizes stacked on top of each other to form a new pattern. I hope these creative ideas would inspire you to create a unique art. Here's the spatial reasoning for the octagon size. Fold the right edge to the center line. Their difference is known. Then fold the left edge to the center. Now look at this triangle. It is an isosceles triangle with 2 sides equal. Twice this length is the side of the octagon. The top angle here is 2/4 or 1/2 of the right angle. So the module has an angle of 45 degrees. The blue triangle is isosceles with 2 equal angles, and the 3 angles add up to the 180 degrees. So this angle is 180 minus 45 divided by 2. For this right triangle, 2 sides are known. The hypotenuse C can be obtained by a Pythagorean theorem. It is the half of the octagon diameter, which can be obtained as this number.